So now daily question 200 number of islands given an m plus n 2-digit binary grid which represents a map of ones land and zeros water. Return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all 4 edges of the grid are all surrounded by water. The outside is all surrounded by water. Example 1. 1 1 1 1 1 0 1 1 0 1 1 1 1 0 0 0 or 0 output 1. It's only one island because this is connected to this all connected. And the second example 2. 1 island, 2 island, 3 island, 3 island. Constraints. Grid length, grid I length, row and column. Greater or equal than 1, less or equal than 300. Grid ij is 0 or 1. Notice this is a chart, not a number. A chart. So let's write it. 200 this. I have written the code before. Have a brief introduction of this. This is Java repo. It's some code written before. It's very helpful for write the test case. Complex pair represents any data including the NUL, because the test case may have some NUL data. And linked list helper, some helper to linked list, and tree helper, some helper to trees. The Java is here. The repo is here. Confirm and confirm. What happened? Oh. the repo is public. I will paste this on the video link. So okay. So go to 200 this. Repeat this. This is somewhat easy. Format it. I use the C format and the hotkey to format the file very easily. This is somewhat easy, simple, because we can just loop every node, every position, and if it is a 1, then we update it to then we DFS it and add the return value, and let's draw it. It's not very hard. 1 1 4 1 and 0, and 1 1 0 1 0 1 1 3 0 and all 0. All 0 can be omitted here. There is only one one island. We just loop every node and then DFS it. If it is 1, we change it to 2. And if it is not 1, we just return. Then we check its neighbors. The second example 2, 1 1 3 0 and 2 1 3 0 and 1 4 0 and 2 1 and 3 0. There are 1 island, 2 islands, 3 islands. Yeah, 3 islands in all. First, we loop every cell. Second, for every cell, we just check the value is 1. If it is not 1, we just return. This is a DFS. If it is 1, we just add the return value, then DFS every node. So when we DFS a node, if the position X, I, and J is valid, then we is not. If the check the I and J position index is valid. If it is not valid, we just return. And then if it is valid, if the value is not 1, then we just return. And if the value is 1, then we just DFS is left, right, for any cell. We just iterate it. We just DFS its left, I, J, right, yeah, the 4 neighbors of this node, then everything works and return the return value. Okay, let's write it. It's somewhat easy. It's not 1, it's a char 1. Yeah. Then we need a DFS, and we need to call the DFS inner. Yeah, so we need to define it as a function. We just capture everything here. First, we check the index is valid. Second, we check the value. Is valid. Yeah. Then we just set to an invalid value to avoid the null back. This is not a very good idea. If we can, in actual fact, we can use another grid to identify the visited name with. Yeah, but to simplify the algorithm, I use this. This will change the grid's data. Yeah, not a very good solution. Or we can just copy it inner. Yeah, if we want to use the grid's data after the call of this function. This code can be optimized. Yeah. Only 2 lines. How simple. This is perfect. Then we just def is left, is top, is right, yeah. The 4 neighbors, and return the return value. Then everything works. Okay, let's test it. Okay, everything works. Let's submit. Have a test. Submit. Okay, good. Very efficient, yeah. Somewhat, yeah. Oh. This. Oh, it's just removed or changed the data in there. Okay, so just on time complexity and space complexity. The time complexity of this solution is very not easy to calculate, but if the m represents the row and the n represents the core, it is OMN, because every node is accessed only once, and the DFs may have some cost, but it will cost only one time. Then the second time the node will not be accessed because it is updated. And the space, we don't have any extra data cost, space cost, yeah, just 3 integers here, just 3 integers. We even don't make the vector bore for width. We may optimize this code width, yeah. Like this, to avoid the change of this grid. Yeah. It is always a good habit to keep the data unchanged in a function, and we can change this to const. Yeah. But I will not show the implementation here. It is also very easy. Okay, so anything else about this question, or somewhat similar to this question? This is not a very hard problem. Very easy DFS, yeah. Okay, so this is today's daily question. Thanks very much.